Hello everybody, I'm Mayan Kaufman. Welcome to this video, to this screencast. We are going to try together to learn how to do this kind of map. We'll work with QGIS software, which is open source GIS software. GIS stands for Geographical Information System, and we'll work with various datasets, but mainly with the ACLED dataset, which is the On-Conflict Location and Event Data project, the ACLED project. So first, you might have seen that here you have something on top of your window, the drawing of a mouse, and when I'm clicking my mouse somewhere, you see that it does change the color. So now it's blue when it's a left click. If I do a right click, it becomes yellow, green. When I'm using the mouse wheel, it shows an arrow on the mouse wheel. And as well, you can see what I'm typing. So for example, if I want to go to the settings menu, I can click on settings, or I can use Alt S, and you see that it shows Alt S on your screen on the top near the image of my face. Okay, so this is for you to be able to follow what I'm doing, and I've added a circle right in the middle of the mouse, so around the mouse, so that you can see the mouse better. It's based on widescreen. Okay, so we are going to see what we can do with QGIS. I will show a few examples and then we'll start to work. So as you can see, I have loaded a file. We'll see later on how we can load this file. Those are violent events or protests across Ukraine from the ACLED dataset. And see that we can zoom with the mouse wheel, okay, or we can use the zoom buttons, for example, to zoom into the eastern part of Ukraine where there are a lot of events. Okay, obviously just having points is not very informative. So for example, we have here selected events that are that concern journalists only. Okay, but we can have also events based by filtered on categories with various symbols. So for example, if I unclick various items in the left pane on the left of your screen, I can keep just battles, or I can use explosions or remote violence. For example, remote violence is, for example, missiles that are sent. Or we could have protests and riots. So we learn how to create those legends. We are in the layers pane. Strategic development, violence against civilians. We'll go into more detail what it is, and also we'll be able to have a look at the data with year by year or month by month, day by day, if we wish. Okay, so here it's this group which I've called ACLED by year. Here we have events for the year 2018, here for the year 2019, in here for the year 2020, and here for the first 8 days of the year 2021. This dataset was downloaded around mid-January 2021, so it has only data up to the 8th of January 2021. And we'll also look at how to add geographical context or social context or whatever pieces of information we want. So those, for example, we can add roads, and we can add names of places. So this is with the Cyrillic alphabet in Ukrainian. It's close to Russian. It's not Russian. We can have this with Latin transliteration, so more readable to English or French speakers. We'll see how to get these pieces of information. But more, I would like to introduce you a little bit more to this wonderful data set, which is ACLED, which I'm showing back here. So ACLED, as I said, is the Armed Conflict Location and Event Data Project. I'm moving the web page from ACLED to your screen. There we go. Okay, this way would be better, I guess. So we are here with on the webpage acleddata.com, and we can have access to a menu where we can get more about ACLED, get the data, get some resources, including guides, get some analysis, know about their special projects, contact, and register to the website. Okay, we go to some of those aspects. So there is a short presentation where we get the link to the data. I will start with this. So the data, there is the data export tool. In the data section of the ACLED datasets, we have a special interest for us to create the data. There's also the data export tool, which is slightly more difficult to use than the created data. So it's more helpful for developers or more advanced users. The easiest dataset to use, they are on the curated data file. You just have to download files, okay? Not that you have to register to get some of the elements of this website, and you can register through the link register on the top, and this is explained, and there is also a guide on how to what are the instructions for registering and accessing the data. But it's quite easy, so well, I managed to get through the steps without the guide, so you can try. So the curated data is where we get the Excel files, for instance. What is very important are the resources. There's guides and methodology, and especially files in the section core methodology and user guides. So you are advised to download and read those files. Those are PDF files. For example, there is the code book. So myself, I've downloaded the code book, and I'm going to show you an extract of it. So that's page 7. Remember, a few minutes ago, we're discussing violent events, especially remote violence. And here, it's explained what remote violence is. It could be chemical weapon, air-drone strike, suicide bomb, shelling artillery missile attack, remote explosive landmine, IED, and grenades. Okay. Of course, you should read the entire codebook. Maybe not before the first use from A to Z. You could actually, but you should, when you use the data, come back to the codebook, read again more detailed way, and also the other files. Some of them that I've downloaded and selected are very interesting to understand what's behind this, what are the data columns, the country coverage, and the methodology, of course. Okay, on the ACLED website, you also have some videos, so you can have a look at those. They're well done. And as I mentioned, the register. Okay, page. Okay, we are going to work on a simple project with data from Ukraine. And you're supposed to have extracted some CSV file, some data saved in a CSV so that you can import it. And that's what we can do with the data in Ukraine. And another example are here are some data from the Democratic Republic of Congo with some bubbles or circles that are with area are proportional to the number here of conflict event, and the colors depend on the type of events as shown in the legend here. Okay. I'm going now to discuss the file organization, but how to organize the data and the pieces of information that we have in order not to get lost. As you can see, there is a lot on the screen. If you can, I suggest, by the way, that you use two displays, two screens, more if you can. And but you should be very careful not to get lost into the data. So or advanced users use their own way to organize data. And this is what I'm going to show you is just a suggestion. So I've created a folder in my hard drive that I call GIS for Geographical Information System. And within the folders, there is a data folder and a projects folder. So projects folders are projects around a topic with the final product, which may be a map or an analysis, whereas the data are the raw pieces of information. So for the moment, I don't have any projects yet in this folder, but I have several folders in data. I split this into vector and raster data. And if we look in vector data, we see ACLED, and we have Europe's for data. Those are the data sets. An extract of the data sets produced for Ukraine that we can map. And this is the documentation with some files taken from the ACLED website. Okay, so what is this? Why have we put some data in the vector and some in a raster? Well, they are very different kind of data. Okay, we can mix them, but they will go in separate layers. Okay, so what are layers? What are vector layers? What are raster layers? I will explain a little bit in just a moment. I'm going to show you now what is the difference between vector data in GIS and raster data in GIS, and a few types of vector data. So let's start with the vector data. Simplest vector data could be just points. So for example, here we have ACLED data in the Democratic Republic of Congo and a few other countries. We could show the same kind of data in different colors, but behind us, it's still exactly the same data. Here you see big bubbles okay? But it's simply that each point here has an attribute which is related to the intensity or violence or number of events. And those are recorded in the files as points. They are not recorded as circles. It's a point, and there are some information within the attribute of the points, which say, okay, there is this amount, and then we decide to show that as a circle or disk. So there are other kinds of data, of vector data. So for example, we have here some administrative data. So the cities or towns are points. So we have points. We have lines like roads or rivers, and we can have polygons. So here we have polygons, entire polygons, and here we have the boundaries. So you see that in the legend, we have similar pieces of information in terms conceptually from political geography point of view, but in terms of data storage, it's quite different. One is a line like this one, and another one is a set of polygons. Okay, so for example, polygons here, you see those are lakes, and if I remove the rivers. So what is interesting about vector data is you may zoom as much as you want. You will never see what we call aliasing, so this kind of imperfect data where it's not very smooth. If you zoom and zoom and zoom and zoom, because what is recorded are the points and then the lines between the points, and no data is recorded in between. So this is contrary to raster data. So here I'm going to show you some raster data sets. It's loading. So often raster data takes much more time to load. Okay. So raster data are like images. So an image is a good example of a raster data. Here you can see the pixels. So for example, when you take a picture with your phone or with a camera, then you are creating a raster data set. So you can see the pixels. Okay, if you zoom out a lot, then you will not see the pixels, but it's still a raster image, okay? And here, for example, we have information on the height, the altitude, and above sea level, and the depth of in the ocean. So we have an image of Africa. So this raster image is quite different from the vector that I'm putting on top of it. Okay, if you look at that scale, it's difficult to know which one is raster, which one is vector. Okay, but if you zoom in a lot, so I'm going to take here. So you see that the lines are very smooth for the admin 0. Admin 0 are countries. So it's NE for natural Earth. So it's a natural Earth data set. So the natural Earth data set here for the admin O countries, the borders, the boundaries, it's a vector data set. Here it's a polygon. While the natural Earth, this one, you see there is an image of a kind of a mosaic. This one is a TIFF file. It's kind of image. Actually, it's an image. Of course, we can have other kinds of images. So another example, I'm going to zoom in a little bit more so you can see even better the pixels. Okay, and I'm going to load. No, not this one. I'm going to load satellite imagery, which is aerial view from Bing. So it will come from the web. So if you would zoom in, you would see the pixels. Oh, Slightly different because here it's actually a set of rasters come from the web. So if you zoom in, actually, Bing gives you another image, which is more detailed. So you end up not seeing the pixels, but those are still bunches of pixels here that they come from the web. So those are raster images, raster files too. But actually, you could it's quite easy to transform vector data into raster data, while the reverse is difficult. So that you better understand, here I've taken in this file, okay, taken the counts in French compte. The counts of events are here as well, and I've created a matrix. So when we say raster file, we could say a matrix. So this is a set of polygons. So it's a vector file, okay? But if we convert that into an image with as many pixels as there are boxes in this set of polygons, then we would have a raster image. And so that's still um, um, a vector data set. Okay, and I'm going to show you another one, which shows better that it is really a vector data set. Because here you see that where there is no events, okay, I've decided that we don't want any polygon, so there is no polygon here, so we can see through it. Okay, while in for example, if we take here this raster dataset by default. So let's say we want to do some study based on the ACLED data for Europe, especially for one single country, which is Ukraine. So we go to ACLED data website, and the easiest is create data files place where we can download files. Here, as I'm recording today, the latest file is dated 22nd of January 2020, but actually I downloaded already the file a few days ago, which was dated on the 8th of January. As you can see, this is the file that I have downloaded, and I'm opening it. So here I'm opening it with LibreOffice Calc. Okay, here we go. Europe. Okay, I open the XLS file. So you can, of course, do exactly the same thing with any spreadsheet editor. So for example, if you have Microsoft Office, you can do it. A huge advantage of having of using LibreOffice Calc and knowing how it works is not only that it is free and open source, which means that you can have it on Linux, as I do, on Mac OS and on Windows, but also because it's free, everybody can get the latest version. And this means that you don't have compatibility issues if several people use several versions of Microsoft Office, which is the case when you don't have the same license for the same software version, okay, across teams that may be international or with partners in various organizations. So here the data is loaded. And of course, as I already said, you should have a look at the codebook. And what we want is we want only data for Ukraine. Okay, so we see that here we have an event ID and the country code, which for Kosovo here is X key X. And so we want to keep this row, this column, sorry, and also we want to keep the first row. So what we do is we are going to freeze the rows above the row where I have put the cursor and the columns on the left, which is this. So you see it adds some black bar here and here, which means that then when I'm going on down, I'm keeping the first row, which is quite helpful here. Okay, and so I want to search to sorry, to do a subset of this data set with only Ukraine. Why am I filtering Ukraine here? I don't have to. I can filter it later on in QGIS, but I'm filtering it here because otherwise the file is huge. And if you don't have a very powerful computer, it may hang or crash, or it may be very, very slow. So here you'll see that there are 40,000 um, um, rows for Ukraine only. If I do control down, I see here that I have for the full Europe, I have 90,000 rows. Okay, so just this hint, control plus arrows, you go to the end of the current um, table or empty space. Okay, so we are going to do this, but first I will search for Ukraine. Control F for find, and I search here Ukraine. Okay, and I want to find the next one. And so here it's searching, and you see that the first record where Ukraine is mentioned, there are Ukrainian protesters, but in Bulgaria, so it's not what we want. So we continue searching. Okay, find the next. Belarusia, not yet. We continue. There are quite a few in Belarusia. Okay, of course, there are other ways to do this. It's just one way. We browse it. We could have searched only in the country field. It would have been faster, slightly more advanced. So we are searching for the first row, which concerns Ukraine only. And I think we are close to it. Oh, Latvia. You see that in the B column, the country is by alphabetical order. So MN, we are close to U. We could have simply done the old way with the page down. And after 2 hours of page down, and you got a tendinitis in your finger, you find a coin. So we'll try to do slightly faster. Russia, we're close enough. I'm going a bit faster here, 3 clicks. So it's interesting to see that Ukrainian actors are mentioned in quite several countries that are close to Ukraine. So okay, we could have searched from the end of the file. It would have been much faster. Okay. So if you want to reproduce it at home, I suggest you search from the end of the file, since the letter U is close to the end of the alphabet. Or you select the country field and search only Ukraine in the country field. It's the Q field. We are at Serbia. We are quite close now. There we go. Oh, was a bit far. Or I click several times. Okay, no worries. So I'm back up. So you see all those events are related to Ukraine. Oops. Okay. And there we go. So you see actually it's not always by alphabetical order of country, but by ISO order. Okay. So here is the first row before Ukraine. So we want to delete all. So be careful, watch carefully. I want to go up to the beginning of the table, selecting all those. So I'm doing Control Shift and the Home. The Home key is, I will try to show you this, is this very key here. Okay, Home. So Control Shift Home. Okay, and you see that it selects up to row 1. So I do Shift to keep the selection and the key, the bottom key. Okay, and here I've selected all the rows that I want to delete. They are, as you see, in blue. So then I can select this. Okay, and I do a right click and I say delete rows. Okay, and voila, I've deleted a few thousands of rows, and I'm going back to the end of the Ukrainian. So actually, I can tell you there are more than 20,000 rows for Ukraine, so I'm going to go a bit faster this way this time. Okay, I could have done this in the beginning, in the first place, actually, with the mouse. Okay. So I have good return after Ukraine. And once I would have filtered this, would save it as a comma separated value text, but first as an Excel file, which is sometimes faster to load. Okay. So here we go. Okay, of course, while we're doing this with LibreOffice Calc or with Excel, which is actually the easiest to use, it's also the less efficient. So actually myself as a data scientist, which I'm also am, when I want to do this, I write a line of code which does this, which says, okay, just from this file, keep only, and it takes me 10 or 20 seconds to write that line of code, and it gets executed very fast. Okay, here we have Macedonia. Ukraine is here. Okay, so this is the last, the first row below the last Ukrainian line. So I'm going to the end of the file again with Control Shift down. Up, this time. Okay, and here I will delete those rows. There are 3,000 rows selected almost. Okay. Right click on the row number and delete rows. And now be careful. If you click save, you'll overwrite your original file. Okay, so we don't want to overwrite our original file. So don't click save. Don't do Control else. Do file save as. Okay, and be careful. Don't click when you will be offered the option to save as. Don't click OK, I want to save it right now because you would overwrite it with the same name. Okay. Here it's saving as you see, but actually it's saving a temporary file because I've put very um, short automated saving time period. Okay. Okay, so I'm adding some text to say, okay, this is Ukraine. Okay, and I'm saving as an Excel file. And then we'll save a copy as a C. Okay, so it says, okay, do you still want? We could save as the ODF format. Yeah, I'm using the Excel. And now I want to save a copy. So saving a copy is like save as, except that it keeps the original file opened and it doesn't leave. It just saves the new one as a copy, but keeps the original one in the original format open. Okay, so we do save a copy, and here we want to save as CSV or similar. It's text CSV format. Okay, and what is extremely important, careful, we want to click Edit Filter Settings. So we want to make sure exactly how it is saved, okay, to make it, I would say, bulletproof, if we may, or dummy-proof. And okay, if we don't do this, it doesn't matter. In many cases, we can still open in QGIS with various filtering. We put some settings on the other side, which I will show soon next. But if we use the settings that I recommend, you will avoid issues, especially if you have to transfer the file to someone else who may not have your abilities. And so just edit the filter settings so that we have this. So I strongly recommend that you use as a character set UTF-8. You don't have to. If you know what you are doing, and usually in Western European countries, in the US, we use other. So, for example, we might use one of those codes, Western Europe, for example. Those are quite um, often used. But UTF-8, the advantage it is internationally recognized, and so it is the way that to make it short, accented characters is the way how accented characters are stored. The best way to store accented characters, because there are many different characters, not only the ones in the US or British alphabet, but there are other languages. And some don't share our Latin alphabet. So with UTF-8, you are quite safe. Okay, the field delimiter, the the easiest to use is the tab. Actually, if you really want a comma separated value, it means it's separated by comma. Okay, so you should take comma. But the problem is that in some cases, there are commas in the fields themselves. Okay, if we put this, then you quote those text cells, so commas within field don't matter much. But still, it makes things a bit harder. The same string delimiter, we have it here. If we use this, you'll see that after svoboda here there is a semicolon. It might be some issues. So if we have tab, because it's very hard to put tabs into a cell, then it will work best. Okay, and we don't want to save the formulas. We don't want to save the cell content as shown. If you do this, and for example, you have a LibreOffice Calc in French, it will save instead of 1/1/2021 for 1st of January this year, it will save 1 janvier 2021 in full words, Janvier for January. So it's harder to import them. Okay, so we export this way, and it's going to save it. Okay, it takes a bit of time because it's a large file. Okay, there we go. And I'm going to show you the file as it is. Okay, hopefully. So it's a huge file. Okay, so okay, as the physicist said when doing experiments, don't do this at home. Okay, you've been warned. I'm trying to open this in a simple text editor. It's not Microsoft Word, it's not LibreOffice Writer, it's a text editor, raw text editor. And but it's a huge file. Okay, so if you do this, it might be very slow if you don't have a fast text editor. And you see here, okay, if I add this, you see that there are tabs after ISO, tab, event country, ID country, okay, and also okay, if I take this the full line, okay, because my screen is not wide enough. So you see that on the first row, we have I'm now going to show you how we can import data from ACLED. So first we have converted them from Excel file into CSV format or delimited text format. So we could create a new project by clicking create a new project, or yeah, I'm going to use the project that I've already opened to put some new data on top of it. Okay, so I'm taking the menu, a layer, add the layer. I want to add a layer. So, what is a layer? Sorry. Those layers, it's like when you stack pieces of information on transparent layers and you put them on your desk and you can see a map. Like an architect would do with several transparent layers, transparent sheets that she or he will do on. So here we have several layers that you can see on the layer on the left, on the layer list. So we'll add a new layer, and that's a vector layer. So add layer, but it's not in the category of vector layer because it's slightly specific one. We have to create it from delimited text. Okay, so it's almost ready for JS, but it needs a specific import procedure. It's not already a GIS file. So we take add delimited text layer. You see that you have some shortcut here. If you could get that automatically by Control Shift letter T on your keyboard. So we select add delimited text layer, and we will have to select a CSV file in the file name. Okay, so enlarging this. Okay, and it shows back the last import categories that I've import specification that I've selected, so it's a bit easier. But in real life, the default one is CSV, comma separated value. So we'll have to select the CSV file from the GIS folder that I've created. So I've put those in data folder. It's vector data from ACLED. and it's for Europe, and that's the original XLS file, and that's the extract for Ukraine with only CSV file. You see that even if it's smaller area, it's a very large file, 18 megabytes. So it was pretty much worth it decreasing the size by selecting a subset of it. So we say click open once we have selected it, or we could type it here. Okay, we could, if we have hundreds of files, we can filter them to find the one we want. Here it's not needed, we just have 2 of them. So we click open, it just adds this in the file name box. This is the layer that we want it to be named. And this is very important, the encoding. This is very important if we have accented characters, like in French or in many languages. Here, if we put CSV, comma separated value, we'll see that the sample data, it's a preview at the bottom of your screen. It's a preview of what we get. We see that there are no vertical lines for the columns. If we take custom delimiters and we select tab, we see the vertical lines and we see that they are columns. But actually, if we take the wrong vertical line, for example, if we take, you see that there are slashes here, explosion / remote violence. If we say that slash is a separator, then explosion gets in one column and remote violence in another one, which is not correct here. It's not the way it should be. For example, the event date is separated by slashes, okay? So you should be very careful what you select here. And this is why tab is the easiest, because it's very hard to put tabs into cells, into the text of a single cell. So it's pretty much safe to say that tab characters are as the delimiter is the one, okay? Here, sometimes we have some examples or documentation or definition in the first lines of the text. So we want to discard the first line, and what will we do here? But here, if we do, we lose the field names. So actually, you see that the first record has indeed field names. If we don't take this, we got field 1, field 2. But okay, obviously, sub-event type is not a piece of information, is the type of information itself, is the field name, okay? And obviously, if we look further to the right, we have countries like Ukraine here, but the word country is not a country, okay? So we need to take first records as field name, and here we see that it works pretty well. Okay, then look at latitude. We have a comma as the decimal separator. If I remove this, then apparently it works. But here, this will not work. Okay, so this you might have, if it's not latitude, longitude, you will have to select it yourself. Longitude is it's east, west. Latitude is north, south. The Y field. Okay, Z is the altitude. We don't need it, and M we won't need it. Okay, so that's the system we use, the geodetic system that we use. So if you have lat long, then this the easiest is to use that one. So make sure that you. So we can see here that it has been effectively loaded. So we don't need this. It stays open in case we just want to import the data sets. We don't. Okay. So here are our data. So let's zoom in and learn a little bit how to use it. So if we do some right click on the data that we just imported, we see a set of menus and submenus. So we can open the attribute table. The attribute table is a table of attributes. So it contains all the pieces of information, and but in most vector cases doesn't contain necessarily the coordinates. Also, it might. So here it's loading. We have a lot of features. So features here, because it's a point, it's a set of points. Each feature is a point. So we have about 40,000 features. So it's why it's very slow. Okay, it can be sluggish. And here we can see this. So obviously we will not wait several seconds each time we want to do something else. So we have to save that file in a format which is much faster than CSV, and that's what we are going to do right now. Okay, so you recognize the data that were in the Excel file. So I'm closing this, and I'm doing right click again, and I'm doing an export. We want to save the features, so all the points, and we'll save that in the same data folder as a geo package. We could select the fields that we want to export. We want to export everything. The geometry type, you see the point, line, string, polygons, or geometry collection. Here it's a point, but automatically we'll find out it's a point. So we don't need to change many options here. Just the format, GeoPackage is nice. There are other formats. For example, if you want to work with S3 software, you will use S3 shapefile. Okay, you can export to another kind of CSV if you want, and there are many formats. Specialized is quite fast and helpful format to use as well. So we will select our file and the place where we want to save it. So I will put that in GIS. Okay, the data. It's a vector file in ACLED. It's for Europe. And which name will I take? Well, I will take the name from, because I'm a bit lazy. I'm opening another window. Okay, you could simply type the name, but I'm a bit lazy. So I'm opening another window with a file manager. And in this other window, I take the file. This is the CSV file. Okay, don't delete it. Don't overwrite it. And I press here F2 on my computer, which allows me to take the left part of the name before the point. And I do Control C for copy and escape to escape. And then I remove this. And I paste this here with Control V. Okay, like Control V, it looks like some glue. You glue it. Okay, and it will automatically add the file name extension, which is GP key G for GeoPackage. And I save it. So when I click save, actually it just saves the name. It doesn't save the file. Okay. So here we still use this geodetic system, or geodetic system 84, which is very widely used. We could select fields. We don't. We keep them all selected. And we want to add the saved file to map. You don't have to do this. If you click this, it will save the file, but it will not add it back to the current project. So I want to add it. So I click OK now. And you see at the bottom, it's saving. It takes some time, but it's saving the file in my folder. So I'm going to show you what it is doing in the meantime. You see the file is growing and is getting saved. Okay, it's almost done. Okay, we have some magic coming on now. And you see here, I'm refreshing. Okay, my file has been saved here. Okay, and you can see that it has been added. So how to know which one is each one? Okay, I remember that the one before was yellow, but just I want to be sure. If I put here, it says, oh, it's a JPQG file. Okay, another way is you right click on it, you look at the properties, and you see that it is the file that we had just saved. So this is the correct file to work with. We look in the information, we see the file, and we see the storage type, and the encoding is UTF-8. It works well for when we have several languages together, and it can contain all languages. Okay, so we don't need the CSV here. So what we are going to do, okay, is we right click on the CSV layer and we say remove layer. Okay, remove one legend and twist. We do yes. This will not delete the file. It will just remove it from the map. Okay, I prove it. Okay, when I'm back here, the CSV file is still there on my hard drive. Okay, it just removed from the map. Okay, then I want to have it. Okay, now this way. Now, what can we do with this? We can create various things. For example, we can classify the data according to types. So to do this well, we do need to have a careful look at the documentation. So you should download the documentation and with it, please do it now. I will wait. Okay, I guess you paused the video, and now if you are back, it means that you downloaded the video, the PDF file from ACLED website, the codebook, and you got some pieces of information that are how things are coded there. So I would like to show it to you. And okay, so we have our data columns. It's on page 4 of the PDF file. Okay, here it comes. And in the rest of the document, there are more details on what they need, what they mean exactly. But one kind of attribute that is of interest is event type, the type of event. So there is a description of what it is. So let's have a look at this event type. And we can use the attribute table that we could get from here. You see, open attribute table, or we can get through the icon here, open attribute table, or with F6. So this will open the attribute table. So it's loading. Okay, I'm removing this. Okay, here we go. So in effect, we can see that in event type, we have protests, explosions, violence against civilians, battles, etc. So we want to show that with different colors, and we are going to. So I'm closing it. And I go to the, I do a right click and I go in the submenu in properties. And I will change the symbology. So here we have a single symbol, which is the same. So we could change it. Okay, it's not very interesting to change just this, but well, it works. What we want is categories. So we say it's categorized because it's qualitative values. If we had quantitative values, we could use graduated, okay, for example. So let's have it categorized. So we don't have any categories. We could create manually categories, add categories, but there is a simpler way, which is to use the button classify. But first we need to know which value, which field or which column in the attributes, which attribute we want to show. And the attribute we want to show, you remember from the codebook, is the event type. So here it says, okay, the event type, you got the icon ABC next to it. So it simply says it's a string. It's a set of characters. Whereas the year, for example, says 1, 2, 3. It's an integer. Okay. So here event type is a string. Okay. And we just click classify. And it's with the values, it suggests a legend. We could change the legend here if we want. I'm not going to do this, but now you know where you can change the legend. There are other places. And we can change the colors. For example, we don't want other values because here we know that we already have all values and I want to have battles maybe in red. So I double click on battles and I select a different color. You could use fancy symbols like that one, but the fancier the symbols, the longest they take to display. So except if you have a very powerful computer, don't do this just to work. Okay, if you want to publish it in your famous magazine, news magazines, yes, but you might need a decent computer. Okay, so just to work with, we'll do it this way. And when I click apply, it will not close the window. So we are continuing our work on the ACLED data for Ukraine. And so we have loaded the file, the CSV file that we saved as a geopackage for speed. And we are going to make a copy of this. So we just do duplicate layer and create a copy. It's using the same data source. Okay, so we can check this by just showing this. Okay, they are identical. Okay, for the rest of the analysis, I'm adding places and words, but I will keep the boundaries. So actually, I need this. I don't want this. Okay, so we have a better look at Ukraine. Okay, and we are going to study a social movement, particular one, which is one which defends, which is of defense of the freedom of press in conflict areas. So a very well-known organization is Reporters Without Borders, in French, Reporters Sans Frontières, or SF. And they study fatalities or injuries among journalists, including when they are in conflict settings, and will study what kind of movement is around this organization. And actually, there were protests, as we will see together, related to journalism in Ukraine. So we have this copy and we want to focus on journalism. So we are changing the name of the file. We move geopackage. We say journalists. Journalists, okay. And actually we'll search. So we already got that there are many attributes within the document, and one interesting attribute is a free text attribute, which is made of text. So I'm going to show you the table, which is currently loading. Okay. It should be there. I'll go. So this is unfiltered yet. Okay. There is no filter, so we got all the events. And we could use some filters here. Select rows and filter here. We could organize columns. Actually, we're going to do this. For example, here we are pretty much interested in not all events. Okay, so I've clicked the organize column events. I will deselect all and select only the ones that I'm interested in. And just to display when I'm showing the table. And these will be, I guess these, we can change that later. So we want the event type, the servant types, information on actors, the date. Okay. And that's already, we could add the source, obviously. Okay. But this is quite already quite something. The advantage here is that we can look only at the fields that we want. And what we're going to do is to search data within that note field. Okay, so I'm closing this and I will create what we call a filter. Okay, so for those who know query languages, it's like in structured query languages, SQL, structured query language, but actually, if you've already done a search on an academic library, even a bookstore, or on social science websites for scientific journals, for example, JSTOR, you will recognize the kind of search that we're going to do. So I'm doing a right click. Remember the green button on my mouse and filter. There we go. And we have a query builder. So it's actually a query. So the fields listed here are the kind of the name of the columns in which we can search for information. So for example, we could search for event type. So if I click event type and I want a sample of event types, it searches for a sample. I can try to find them all. Here, the sample was good. Sample is helpful if we have many fields or a huge data set. For example, searching for samples for notes. Okay, it will give me a few notes. Okay, if I search all notes, since there is no or almost no single independent notes, it will return the entire data set, which is slow. Okay, could search for samples for fatalities. So for example, if we want to find event with one single fatality and not two, we will double click fatalities and we have fatalities equals 1. Not that here, I've done this with the mouse, but obviously I could do it this way. So you see as you type, it suggests it. So note that double quotes are for field names, while single quotes are for strings. So here I have a query, I'm testing this, and I see that there are 942 rows that are displayed here that are that meet the filter expression fatalities equal 1. Okay. Just to continue on the source. Okay, because I mentioned the strings, how we can filter for source. So, okay, I want to have, when the source is like this, okay, so you see, but single quotes here. So double quotes here for the field name, and the values is single quoted when it's a string, and no quote when it's a number, for example, an integer. And you can see that there are 3,000 rows like this. But interestingly, we have other sources where we have a semicolon and other kind of strings afterwards, or possibly before. So we want to have take it all character, wild card. In French, this is nous voulons un joker, and this is it. This is the percentage character. So you'll see that we get more answers with this, and then we'll get back. I'm getting closer to what we want, which is journalists. Oops. Oh, it's not equal to. Oh, my mistake. It's like. So when we use a wildcard character, we want the operator to be like. Okay. Oh, you see, it works. So we have many more answers than when we add just equals to DPR Armed Forces Police Services. Okay, and now we want journalists. Okay, so we'll do a similar filter now that we are professionals with those filters. And we search for this in notes. So take notes, and we know it's like. Okay, actually, we will have a look at like, and okay, while samples not very helpful, here we do. Oh, we want journalists. So we want, when they speak about journalists in the notes, but maybe they speak about one single journalist. So if we take journalists like this in the singular, it will work, but it will take journalists with an S, because we have those two wildcards before and after. And if we test this, we have 158 rows. We use this filter, not like journalists, which returns 158 rows. Note that in some cases we should use I like. This depends on how the file is saved. Here it's a geo package. So I like is made for other kinds of data sets where the storing engine behind this supports searching distinctively between journalists with a capital letter and journalists with a lowercase letter. Here, like is case insensitive in this case, and I'm going to prove it to you. If I put journalists, I will get exactly the same number of answers. Okay, so here it doesn't matter if you put it uppercase, lowercase, we can use like. Okay, so we have our notes. They contained the word journalists. So we click OK. And we see that here we have the new icon with the filter icon. Okay. And we can do something more. Right click on mouse. And we select show feature count. We do the same just to be able to compare with the one above. Show feature count. And we see that we had more than 40,000 data points, and we just have 158 related to journalists, singular or plural, in Ukraine in that data set. Okay, so I'm going to show you this, and I've actually prepared a few ones that I wanted to share with you. There we go. So if you want to open it, you just right click and open attribute table, which I've already done with some selections. Okay, here we go. I'm resizing that to the display that I'm sharing with you. And so we have those 158 events. Okay, still too wide. There we go. Okay. So if we look at those, we see that, okay, I've clicked on the fatalities to filter in decreasing order the number of fatalities, which is an integer, okay, which contains value 1. So there are 3 fatalities in this event, okay. Here, one journalist died, was killed. Then here, an investigative journalist was beaten and died in hospital more than a month later. And here you see journalists, so camera operator and sound engineer. They were one of them was killed. No, not the journalists were killed, but they were close to someone who was killed. Okay, so we see that we should be careful. It's not because we have journalists that those are fatalities. And however, we can see that here, for example, no one was killed, but a civilian journalist was under fire. So if we continue looking at this, we see that here it's not a killing, but it's a commemoration of a journalist, Pavlo Sheremet. And so we look at this. So there's suspicion of ordering a murder. If we look at all the fields, okay, I've read several of them, and I found out that this journalist Sheremet you see here is cited as well. So who is Pavlo Sheremet? So here we have a copy of a BBC webpage showing what happened. So Pavel Sheremet was a journalist. He was killed in his car in a car bomb. If we look at Reporters Sans Frontières, Reporters Without Borders, and we search for Sheremet, we have 8 results, and one of them being this one, Ukraine, well-known journalist killed by car bomb. We see that sometimes it's Sheremet with CH, sometimes SH. Okay, this is just transliteration because Ukrainian uses the Cyrillic alphabet. Okay. This is an information agency which reports information from Reporters Without Borders. Who killed Pavla, says this this document. And the one here, and also you could look at what Wikipedia says about this. By the way, here we have the Cyrillic name of Pavel Sheremet. So we are going to search for this in our data sets. So I'm closing this. Okay, and I'm doing a copy of the first layer in which we had all Ukraine event. Duplicate layer is what I need. Okay. So, and I'm going to call this Sheremet. and I'm making a filter out of it. Okay, I will remove the words GeoPackage. I don't need it. Okay, and filter. There we go. Okay, so we should search in the notes like Sheremet. Okay. Oops. Oh, okay. I did double quotes here. So my mistake. It's double quotes for fields, single quotes for patterns or for strings. So this should work. There we go. So 31 words. So you remember that Sheremet in one Reporters Without Borders web page was written with CH. Okay, you remember this? I'm showing this back. Sheremet hearing adjourned. So we might want to, just to be sure, we want to have both. So I'm doing two criteria, and the OR is an inclusive OR. So it's either the first row, which works, or the second row of the criteria, or both. Okay, and we could put this in a single line. This is the same, exact same test. Okay, so I'm doing the test. I have exactly the same number of rows. So actually, it's not very helpful to have this. We could, okay, just wanting to show you something that we can add comments. So you see that since I've put dashes like this, then it's become gray and italic. It means that it's a comment. So I can type blah, 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 anything. It's just a comment. Okay, it's ignored when I'm doing the filtering. Just for you, for us, for me, to be able to communicate with human users who need comments to understand what computers do. Computers don't need comments. They just ignore them. Okay, so more helpful comments could be something like this. We want to make sure that both transliterations are taken into account. It's a bit long, so I'm putting this in 2 rows. Okay, so this is correct. Okay, I'm doing the test. Okay, so it's fine. So, okay, we don't want to perform a test which is not fully necessary. So, okay, when a row will work, does match this, it will stop here. It will not look whether the second criteria is met. But when a note doesn't met this, it will look at the other. And we now know that it's unnecessary. So just to save a bit of time and increase processing speed, I'm putting this in comments, but I'm keeping the comment. So maybe it's better. No, it's better if I do it this way. Okay. So now it's a more advanced use of the fields filter and of comments. So you can see we can sometimes write entire we can use entire programs here. We can develop entire programs, lines of codes here. They could be quite complex. We can use functions, not only operators. Okay, so just for last time, checking that we have this. Okay, and I click OK. There we go. Okay, and I'm saving my work. Okay, and now looking at the data that are filtered, you can open this here with open attribute table. And okay, I had already opened it, so I will resize it for you on your screen. There we go. Okay, so here we kind of see several events, 31 events that are related to this date journalist, and we can see that most of them. Okay, maybe we can do something. Organize columns. We want the year as well. Okay. Okay. So you can see that there are two events in 2018, 2019, two protests, and then in 2020, riots, protests. We're going to study this slightly more in a few seconds, but first, it's interesting to look. So what is interesting here, if we filter, if we order by notes, you see that, or by date, by the way, you see that there are a lot which happened on the 4th of July 2020. And of course you can read this, and you see that in some cases, here we have Donbass veterans. In some cases, the description are very close from one event to another. Okay, possibly they come from the same source, so you can investigate the source. Okay. Okay, for Sheremet. And now we want to have a better look at the kind of events. Sorry, so I'm going to open it back. Mistake. Okay, and the kind of interaction between which kind of actors. So if you have not done so, you should read the code books, and you will see what those inter 1, inter 2 means. And here they are related to the actors, actor 1, the kind of actor 1 and actor 2. So there are subcategories. Well, so there are categories and kind of associated actors that are related to those. And we can see that, okay, what is interesting is the interaction. So I'm ordering by interaction. So the interaction are two numbers. So it reads, well, it looks like 15 here, but it's actually 1, 5. Okay, it's not 15, it's 1, 5. There is no 15 code per se. It's the 1 and 5 code, and together they do something which looks like 15, but it's actually you take the two both together, and here we could have, so when there is only one actor, the first actor gets the first position, and then there is 0, like here, 60. When there are two actors, the lowest number gets first, so we got 15 instead of 51. Okay, just that we got a lower code. It's just a convention. It could have been the other way around. Okay, just for us, so that even in cases where we would have 1, 5 instead of 5, 1, there would still be an interaction between actors of type 1 and actors of type 5, which in this case are rioters, and actors of type 1 are police forces. So we can see that we have 1, 5, 6, 0, and okay, I need to move the bottom of the screen here for you. Okay, and if we go down, we have also 6, 6. So protesters, that's interesting. So it's actually interesting. Protesters against protesters. What happened? Okay, so if we look at the notes, we have a description of what happened, which is quite enlightening, interesting. Okay, here we go. So actually, there were two protests. Some were in defense of the memory of the killed journalist Pavel Sheremet, and in order to make justice, they wanted fair investigation. And the other one is another group of protests who they support the current suspects and they demand evidence of the guilt. So there were two, and it doesn't say if there were any violence between them. Apparently there were not. But if you look at the other notes, you'll see that actually there were quite many cases where there were some events with supporters of Sheremet and some other events supporters of the suspects. So it's quite interesting that there was a contentious issue here, and the social movement is behind this. It is that of people fighting for the freedom of press, so Reporters Sans Frontières, Reporters Without Borders, but also local organizations, civil rights organizations. Okay, they are facing people who support the rights of the suspects, and potentially there could be some interaction between them that could become violent at some point. Okay, so that's interesting to keep an eye on this. And so to do so, we look at this interaction code here, this field. So we've seen that there are several categories which are made of two sets of categories, two fields. Okay, and here we go. So I'm doing a copy of this again, duplicate, and I will call this interaction. Interaction categories, let's say. Okay, maybe a better title could come later. So I've got this. Okay, I'm saving it, and I'm opening the properties, and I will look into the symbology. So we'll create symbols. Okay, and we want categories. We want it to be categorized on that value that I just mentioned, which is the interaction. Okay, and classify it. Okay, and here we have the three values that can be seen. Okay, of course we could change the legend, could be helpful. Okay, this is left as an exercise to the user. And here, for example, you see, okay, maybe I will put some more information like okay, okay, not very helpful. My CL is a bit rusty. I think I do have something here. Okay, near Brovary and Kiev. Okay, near Kiev, we see that there are those events of type 1.5 and 60. Okay, so we can look at the other places where there are events related to these journalists. Okay, so I'm disabling this again, but we want to see the borders. Should be this. Okay, it helps. Okay, so we see that most of the interaction in 2020, and maybe a bit before, there were two events before that here, are around Kiev. And when it's not on Kiev, it's more on the western side, which is not the Prussian side, which is more on the uh, eastern part. Okay, so here that's interesting to look at the pattern of